The next part that we are doing is how we are going to distinguish. That is, there is a chemical test to distinguish between an alkane and an alkene or even alkyne. Okay, alkane will be containing only single bonded. Alkane will be containing only single bonds, so it is going to be a saturated compound. While alkene will be containing a double bond, this is known as unsaturated compound. Okay, it means a double bond is present. Even alkyne, because alkyne is not there in the syllabus, that contains triple bond, that is also unsaturated. That is also going to give you this chemical test, which is going to be bromine water test. Okay, now whether it is alkane or alkene, it is going to be colorless. Bromine water is reddish brown in color. If you are going to add this bromine water, there is no chemical reaction taking place for alkanes, so there is no reaction, so this reddish brown color remains unchanged. While here there is a chemical reaction, here a double bond is there. This bromine which is there, it is getting added, so this double bond will break. This bond between bromine will break. This bromine will get attached here, the second bromine atom will get attached here. This is the compound that we are getting. It is 1,2-dibromoethane. This is a colorless compound, so on addition of bromine water, it turns colorless. I'm just going to show you that demonstration experiment.
The tube on the left contains the saturated hydrocarbon cyclohexane. The tube on the right contains the unsaturated hydrocarbon cyclohexene. First, brown-red bromine is added drop by drop to the left-hand tube containing saturated hydrocarbon. As the bromine is added, it dissolves in the cyclohexane. The color remains when the solution is stirred because bromine does not react with saturated hydrocarbon. Now, liquid bromine is added to the unsaturated hydrocarbon cyclohexene. The red-brown color disappears as the bromine mixes with the cyclohexene. This is because the bromine reacts with cyclohexene, adding to the double bond.
Whenever any substance is getting added to a double bond, such reaction is known as addition reaction. Addition reaction applies only to double bonded or triple bonded compounds. The double bonded compounds are alkenes and triple bonded compounds are alkynes. Of course, this is not there in the syllabus. We have to do addition reaction of alkenes. Okay, first I'm going to write down the definition, which you will copy down, and then we are going to take some examples. So this is the definition of addition reaction. The reaction in which a substance gets added to form a single product. So one single product will be formed. This reaction is called as addition reaction. The addition can be of hydrogen. The addition can be of bromine, as we have seen in the previous example. It can be of chlorine, or one atom can be of hydrogen and one atom can be of chlorine or bromine. Okay, for each one of these, if the addition of hydrogen is there, it is going to be hydrogenation. If the addition of bromine is there, we call bromination. If addition of chlorine is there, we call chlorination. If one hydrogen and one halogen, that is chlorine or bromine, is there, HCl or HBr, we will call it hydrohalogenation. Okay, I'm just going to make you write all of these things. You can just take them down. If you have any questions, you can ask me. So addition of hydrogen will be hydrogenation. This is done for hydrogenation of vegetable oils. This is going to give you saturated fats or saturated oils. Then halogenation is addition of halogen. If chlorine is added, it is called chlorination. If bromine is added, it is called bromination. If one atom is H and another one is halogen, we call it hydrohalogenation. This will be hydrochlorination and this will be hydrobromination. Just take down everything, whatever is there on screen. So the next part is, this is a compound A that is given a double bond. This is a compound B. Obviously this is chlorine. Okay, here the addition reaction, it will be undergoing addition reaction. You are supposed to work out the structural formula of these and also write the name of the compound C that is formed. Just copy down that part, write it in your notebook and send it to me. I will just check that. Now the definition of substitution reactions, it's meant only for saturated compounds or saturated hydrocarbons, that is for alkanes only, single bonded compounds only. The definition is, it's a reaction in which the hydrogen atom from an alkane is substituted by another atom or group of atoms. I'm going to consider over here one of the examples and then you can take down everything. Okay, this is now CH4 is there, methane. This is way to react with chlorine, that is Cl2. Okay, so basically what is going to happen over here in this reaction is, okay, this hydrogen which is there, it will get removed, it will get replaced or substituted with this chlorine atom, and this hydrogen atom which is there, it will get attached to this chlorine atom. It means here the hydrogen atom is getting substituted by chlorine atom. This is a very important substitution reaction. Many past paper questions are there based on this. The condition that is required is very, very important. It is ultraviolet light or UV light. But then you can give the name to the compound product that is formed. This is one step in which one hydrogen atom is substituted with one chlorine atom. If more chlorine is available, certainly you can see over here 1, 2, 3 more hydrogen atoms are also available. So in the similar way, you can also remove this hydrogen atom, react it with chlorine, and then of course it is going to form the compound with 2 chlorine atoms. You will also write the name for that, which you are going to do it by yourself, and then plus of course HCl will be there. This is a complete expanded structure or structural formula I have shown you. You can also write it in a simple way also. Sometimes they can ask you like this also. The reaction will be CH4 plus this is Cl2. This is going to give you CH3Cl, and plus this is going to be HCl. You're going to copy down everything. You will write the name for this, and there is a question in one of the past papers, write another substitution reaction for this given reaction for methane and chlorine, which I already explained to you. You are supposed to show that with expanded structural formula. You're going to send it to me and I am going to check it. Just take down everything, whatever is there on screen. If you have any questions, you can ask me. Now combustion, that is burning reactions of hydrocarbons. All hydrocarbons on complete combustion will form carbon dioxide and water with release of energy. Therefore, all of these hydrocarbons will be good fuels. Okay, I have taken the first two of the alkanes, CH4, methane, C2H6, ethane, combining with oxygen, giving you carbon dioxide plus water, plus of course heat is produced, which makes it use as a good fuel. Okay, you'll copy down everything and then you are going to balance these equations, and then I'm going to give you a few more examples which you can take it for homework. Now controlled oxidation reactions of alcohols. Alcohol can be oxidized in controlled conditions. It is going to produce aldehyde. We don't have to know that. And further, when it is oxidized, it is going to produce carboxylic acid. So CH3OH, that is methanol, ultimately on controlled oxidation conditions is going to give you methanoic acid. whose formula is going to be HCOOH. So the next part is manufacture of ethanol, that is C2H5OH. Okay, there are basically two methods for preparation of ethanol. One is you can use the petroleum resource ethane on hydration. Hydration means addition of water will give you ethanol. That's a very fast process. Okay, and the second method is with the fermentation of glucose. Okay, yeast can be used as a biocatalyst. Your enzymes will be acting as a catalyst. That of course is a slow process. Both of these processes have certain advantages and disadvantages. So those things I will put them on screen, which is in the form of one of the past paper question that has been asked. Okay. So this will be from ethane. This is a fast process, C2H4. This is addition of water. Okay, as we have done previous addition reaction, at one stage H will get added and another stage OH will get added. So that's going to give you ethanol. That's C2H5OH. This is the reaction glucose that is obtained from plants. Okay, C6H12O6, that's the formula of glucose. It gives you ethanol plus carbon dioxide. Your yeast can be used as a biocatalyst, okay, which carries out the process of fermentation. Okay, you can just take down everything. The disadvantage of this is not renewable resource, while your glucose is a renewable resource. So this part is very, very important. Manufacture of ethanol. Okay, I just forgot to mention over here for addition reaction of hydrogen, especially the catalyst used is nickel, and the temperature of 300 degrees Celsius is required. So that is an important point that you have to add for addition reaction of hydrogen. So the next part is denatured spirit. What does this mean? We are going to add some impurity like methanol that is added to ethanol, C2H5OH. This is especially in industries. Okay, because methanol is a deadly poisonous alcohol and ethanol is used for drinking purpose. Okay, so that people do not drink away this ethanol. That's why we are going to add over your methanol that will be added, and this mixture that is added is known as denatured spirit. The next part is the property of ethanoic acid. Ethanoic acid behaves like a weak acid when dissolved in water. Okay, so when it is in presence of water, obviously this H plus will go with water. It is going to form H3O plus, that is hydronium ion. Okay, and whatever the remaining part which is there, CH3COO with the negative charge, that is going to be the ethanoate ion. Now, why do we call it a weak acid? Because this is an organic acid. This will be a weak acid because the amount of separation of formation of these hydronium ion and ethanoate ion that is taking place is approximately 5%. It means if there are 100 molecules of CH3COOH, only 5 of them will get separated into this and this. Other 95 of them are going to remain intact. As it is opposite in case of strong acids like mineral acids like hydrochloric acid, HCl, HNO3, H2SO4, where this separation is taking place above 90%. So that is going to be a strong acid. So this is a weak acid with low separation, low degree of dissociation, forming fewer number of hydronium ions. And of course the other negative ion is the ethanoate ion. The other property of acid is, of course, because it is an acid, blue litmus will turn red. All indicator properties, it is going to show the pH which is going to be there. It will be slightly below 7. Okay, if 7 is the pH of the neutral substance, if you go above, it is going to be alkaline. If it is 6 or 5, it is going to be weakly acidic. This is moderately strong acid, and this is going to be, if the pH is 1 to 3, then it is going to be a very strong acid. Okay, so this is about the acidic properties, the first acidic property of ethanoic acid. Another thing is obviously any carbonate or bicarbonate because it is an acid, it's going to produce effervescence of carbon dioxide. So we can take that equation as well. Carbonate is there, sodium carbonate I am taking. This H will get replaced with Na, so this is going to become CH3COO. H gets displaced with Na. The remaining part is water and carbon dioxide. Balancing of this equation is simple. Na2 is there, so you make this 2. So this will become 2. And that's it. This is balanced. The name of this compound is going to be sodium ethanoate. Okay, you will just take down all of these things and then we'll proceed to the next topic. The next part that we are doing is fractional distillation of crude oil. Crude oil is basically obtained from below the Earth's surface, several meters. So this will be containing many different hydrocarbons and many different compounds will be present. These all will be petroleum. We are going to separate that out by the process that is known as fractional distillation. Okay, so from here we are going to heat it and then we are going to cool it and it is going to go in the downward direction. Okay, in fact we are going to heat it. Okay, now the fractions means the portion or the parts which are going to get separated out because of the differences in their boiling points. Okay, as we are going down over here, the boiling point and viscosity means ability to flow, this increases. So this will be the least boiling substances. As we have said earlier that the carbon chain length, lesser the carbon chain length, its melting point, boiling point will be less. And these uses are also important. In many past papers they have been asked these uses. If there are 1 to 4 carbon atoms in a chain, it is used, the name of the fraction is refinery gas. Okay, it's used as bottle gas for cooking, that is LPG cylinder and so on. Gasoline, that is the second fraction, it is C5 to C6, that is, this is the carbon chain length. This is used as fuel for cars. As you are going down over here, the boiling point of the substance is increasing. The next fraction that we are taking is naphtha. The carbon chain length is C6 to C10. Okay, the use of this is the starting point of feedback for many chemicals and plastics. Feedstock for many chemicals and plastics. So basically it will be used in overall plastic manufacturing and many chemical industries. Next part is the paraffin. That's also known as kerosene. The carbon chain length is C10 to C15. This is not so much important, but the order which is there, that is important, and the use. This is used for fuel for aircraft, oil stoves and lamps. The next fraction is diesel, that is gas oil. Is used for fuel for diesel engines. The next fraction is fuel oil. Is fuel for power stations, that is thermal power station, in order to produce heat and heating systems. Lubricating fraction, this is used in machinery as lubricants, in waxes and polishes. The last fraction which is there is bitumen. Okay, this is having a quite high melting point. This is used for road surfaces, so that's basically the black substance that you find. You are just going to copy down this entire chart and then we will continue with the next part.